In this lesson, we are going to talk about the mathematical operations in MATLAB. Let's say we want to calculate 7 plus 8 divided by 2. So when we press enter, the answer given will be equal to 11, where in this case 8 divided by 2 will be performed first. We can also use brackets in the calculation. For example, if we put 7 plus 8 within a bracket divided by 2, when we press enter, we can see that 7 plus 8 is performed first, which is equal to 15, and then divided by 2, this will give an answer of 7.5. Whereas in the first example, 8 divided by 2 will give 4, 7 plus 4 is equal to 11. Okay, next, if we perform, for example, 4 plus 5 divided by 3 plus 2, then in this case, 5 divided by 3 will be performed first, and then which will be followed by 4 plus this, and then plus 2, so we'll get an answer of 7.667. We can also perform exponentiation. For example, 5 to the power of 3 divided by 2, and then when we press enter, this exponentiation will be executed first. So 5 to the power of 3 will be executed first, and then will be this answer will be divided by 2, so we get 62.5. Another example is, let's say, 27 to the power of 1 divided by 3 plus 32 to the power of 0.2. So when we press enter, the 1 in the bracket will be executed first. So 1 divided by 3 will be executed first, which will be followed by this exponentiation, 27 to the power of this thing, 1 divided by 3, and then 32 to the power of 0.2 will be executed next, and finally the addition will be performed, so we get an answer of 5. We can exclude the bracket here. So what happens here is that, do you see that the answer now is different from what we have previously? So in this case, 27 to the power of 1 will be executed first, and then 32 to the power of 0.2 will be executed next, and then the answer for this will be divided by 3, and then only will be added to this. So what we have is 11. So it is very important for you to really know how to write the mathematical expression so that you will get the correct answer. Okay, now I'm going to demonstrate. For example, we have a very long equation to write in MATLAB. Let's say the equation is very, very long. Then we want to continue to the next line. So what you can write is you put 3 dots here, and then this, you notice that this has turned into blue color. When you press enter, nothing happens. Then you can continue your mathematical expression. So when you press enter, you will get the answer for this thing will be calculated from up here and continue down here until it finish. Then the answer given will be 0.7071. Okay, and if you notice, all the answer is given up to 4 decimal points. For example, let's say we calculated 290 divided by 7, we get 41.4286. So we can change this number, a number of decimal places. You can write, you can change the format. So we write format long. When you press enter, then now you type 290 divided by 7. Now we get longer answer. Now the decimal places has gone up to 15 decimal places instead of 4 decimal places. If you want to change it back to the original, to the default setting, which is 4 decimal places, then we type format short. Now when we perform the same calculation, we get 41.4286. We can change to other display settings such as format short E. When we include the word E here, this means that the answer will be given in a scientific format with e to the power of 1. We can also have format long E, so we get now longer decimal places with e to the power of 1. And there are a lot more display settings. For example, format short G. This will give the best of 5-digit fixed or floating point. So in this case, we get 41.429, 5 digits only. Okay. If we put format long G, then you get 15 digits. We can also use format bank. What format bank does is that it will give you only 2 significant figures. This means that the answer will be written in a currency format. Format bank means currency. Normally we write currency in only 2 significant figures. So that's about display format. As I've mentioned in previous class, whenever we perform a calculation, we are going to have something stored in the workspace over here. So in order for us to clear the workspace, we have to type the command clear. When I type clear, you notice that the workspace is now emptied. There is nothing more in the workspace. And we can also clear the command window so that we can, if we want to start something new, by typing CLC. When you press enter, now your command window is cleared. Alright, so let's go to some elementary math built-in functions. For example, square root. If we want to calculate square root of 4, the command is sqrt in a bracket of 4. When we press enter, we get the answer of 2. Or we can also calculate square root of 81. For example, when we press enter, we get the answer of 9. We can also write an expression. For example, square root of 50 plus 14 times 3. Okay, so what we have here is 9.59. Okay, notice that my answer is now only in 2 significant figures. Why? Because previously I set the format to bank. Now I would like to set the format to short again. When I press enter, I will perform this square root of 50 plus 14 times 3. Then what I get is 9.5917. We can also include a function within a function. For example, square root of 54 plus 9 times another square root of, let's say, 100. Okay, then when we press enter, we get the answer of 12. And bracket is really important here. For example, when I have a bracket here, I have to close it. So when I close a bracket, it highlights this part. So you notice that this closes this bracket, but we have another bracket to close here. If we press enter right now, we will get an error. But then MATLAB already suggested that we need another bracket here. Okay, so when I type a bracket here, this highlights this bracket, so I know that I have closed all the bracket. When I press enter, I will get the answer. What if we want the root of other than 2? So for example, if we want to calculate root of 5 of 80, the built-in function is nth root. So what we want is 80 root of 5. So we write 80, 5. We get 2.4022. So nth root of, for example, 81,2 is actually equal to the square root of 81. Do you get this? 2 is basically the root of the number of root that we want. So now we want 81 root of 2 of 81, which is also equal to square root of 81. But in this case, we want root of 5 of 80, then we have to write nth root 80, 5. Another example, let's say we want nth root of 27, 3. So we should get 3 as an answer. Okay, so because 3 to the power of 3 is 27, right? 3 exponent 3 to the power of 3 is 27. So nth root of 27, 3, the third root of 27 is 3. We can also calculate the exponential. Let's say we want exponential of 5, or which is also equal to, this is actually equal to e to the power of 5. Right, e to the power of 5. So when we press enter, this gives you an answer of 148.4132. You notice here that I put percent here and then it turns green in color. That means that is a comment. I can the comment will not be executed by MATLAB. For example, I write percent symbol here, then I write this is a comment. This will not be performed or calculated by MATLAB. So when I press enter, nothing happens because this is just a comment. But you have to include the percent here. Without the percent, if you, let's say, delete this percent, you press enter, then MATLAB has a problem with this because it does not know what this means. We can also perform a natural logarithm, which is ln, ln. Okay, let's say we want ln of 1000. What is ln of 1000? So to calculate ln of 1000, the command is log 1000. When you press enter, you get 6.9078. For logarithm, base 10 logarithm, we should use a command of log 10 of 1000, for example. Then we get the answer of 3. Okay, do not confuse log with log 10. In your calculator, normally log means log of 10, base of log of base 10, but in MATLAB, log here actually means ln, the natural logarithm. But if you want to calculate log of base 10, then the command is log 10 in bracket 1000. Okay, the last built-in function that I would like to highlight here is that, for example, we want to calculate the factorial. Do you know what factorial is? For example, I want factorial of 5. Factorial of 5 mathematically is written as 5 with exclamation mark like that. That is factorial of 5. This also means, factorial of 5 means 5 times 4 times 3 times 2 times 1. That is what factorial of 5 means. So in MATLAB, we can type in factorial within a bracket 5. This will automatically calculate what factorial of 5 means. You can double check this by calculating 5 times 4 times 3 times 2 times 1. You will get also 120. Okay, next, let's go to trigonometry function in MATLAB. So for example, we can calculate sine, cosine, tangent, and cotangent. If we want to calculate sine of, let's say, pi over 6, this will give an answer of 0.5. But this command, sine of pi over 6, means that the argument in the bracket is in radian. This means that the argument in the bracket is in radian. If you want to calculate something in degrees, the argument within the bracket in degrees, you should use sine d. For example, we want to calculate what is the sine of 30 degrees. So now is what we are calculating is the sine of 30 degrees. So what we get here is also 0.5. The same goes for cos. We can calculate cos d, cos degrees of 30. We get 0.866. For tangent, for example, we have tangent of pi over 6. We have 0.5774. If you want tangent in degrees, then tangent d of, let's say, 30 degrees, we get 0.5774 as well, because pi over 6 is obviously 30 degrees. And also for cotangent, it's either cot or cot d. Cot d 30, cotangent of 30 degrees, we get 1.7321. Okay, that is about the trigonometry function. Next, let's look at the rounding function. Rounding function in MATLAB. So for example, let's calculate 17.5, we get 3.4. So if we want to round this, the answer, we can write round 17 over 5, we get only 3, because 3.4 rounded, it becomes 3. It is rounded to the nearest integer. Another command is, for example, fix, which will round towards 0. Let's say, example, we have 13 divided by 5, the answer is 2.6. And then if we calculate fix 13 divided by 5, we get 2. This will round towards 0, not to the nearest integer. Basically, this is rounding down. If we want to round this up, we use the command ceil. For example, here if we have 11 divided by 5, we get 2.2. So if we use command ceil, 11 divided by 5, we get 3 as an answer. It is going up, it's not going down. Okay, and then another function is floor, to round it towards minus infinity. For example, if we have minus 9 divided by 4, the answer is minus 2.25. So if we use command floor, minus 9 divided by 4, we get an answer of minus 3. It will round towards minus infinity. Another command is to find the remainder. For example, we have 13 divided by 5, which will give an answer of 2.6, but we want to find out what is the remainder of this calculation. So we use command rem 13,5, then we get a remainder of 3, because 13 divided by 5 will become 2, and the remainder of the division is 3. And finally, there is another function called Signum function. Signum function. Okay, this returns 1 if x is more than 0, minus 1 if x is less than 0, and 0 if x is equal to 0. So this is what Signum does. So let's say we want to calculate Signum of 5, then we get the answer of 1, because apparently 5 is more than 0. If we calculate Signum of minus 5, we will get minus 1, because now x in here, the argument is less than 0. So if we calculate Signum of 0, we will get 0. So now we are going to go to variables. Let's say we want x is equal to 15. So when we write x equal to 15, we press enter. MATLAB says here x equal 15. Then in the workspace, x is 15 now is listed here. Okay, let's say we want to calculate x equal to 3 times x minus 12. So x here is equal to 15. So what will be performed here is 3 times 15 minus 12. When we press enter, x now becomes 33, and notice that in the workspace as well, the value of x has changed from 15 to 33. MATLAB automatically updates the current value of the variable. Okay, now let's say we want to assign a is equal to 12. Okay, when we press enter, a equals to 12, and also a is then listed in the workspace. A now equals to 12. Now b, we assign it to be 4. So you see b is equal to 4, then b here is then equal to 4. Okay, please note that the variable assigned in MATLAB is case sensitive. What does this mean is that although we have defined b, the capital B equals to 4, if we type b, MATLAB does not know what small b is. Small letter b is not in the workspace. What we have defined in the workspace in the command window here is the capital B, which is equal to 4. So MATLAB asks here, did you mean capital B? If we say yes, we press enter, then MATLAB returns capital B is equal to 4. Okay, we can perform mathematical operation using the variables that we have created. For example, here we want to calculate C equal to A minus, in the bracket A minus B plus 4t minus A divided by B times 10. Okay, so what we have here is what will be performed first is those within the bracket. So A minus B will be performed first. A is equal to 12, so 12 minus B is 4, 12 minus 4, and then B times 10 will be performed next, and then A divided by B times 10, and then only the addition and subtraction will be performed. And remember from the previous class, if we include semicolon sign at the end, when we press enter, MATLAB will not display the answer. But you can see the answer written here in the workspace. Now C appears in the workspace. C becomes 18. When we type C in the command window, then we press enter, MATLAB gives the answer C equals to 18. So basically this semicolon symbol here suppresses the answer of this. But MATLAB performs the calculation, but it didn't. MATLAB does not display the answer because of this semicolon symbol. We can also type the variable in just one line. For example, A equal to 12, then I put semicolon. B, or I can also put comma, so to enter the next variable. B equal to 4, like what we did previously, and then I put semicolon here, and then I type C equal to A minus B plus 40 minus A divided by B times 10. This is the same mathematical expressions like the previous example. So when I press enter, two things are displayed here by MATLAB. The first one is A equals to 12. Why is this being displayed by MATLAB? Because we did not include semicolon here. I just put a comma, so MATLAB will display this value. And then B equals to 4 will not be displayed because I put semicolon here. And then C, the calculation of this, will also be displayed because I did not include any semicolon at the back. But if you look at the workspace, everything has been recorded. A equals to 12, B has a value of 4, and C is equal to 18. Okay, another thing is that MATLAB variable can consist of more than one letter. For example, I can define ABB equal to 72. When I press enter, you see now ABB here is equal to 72. Okay. I can also type ABB equals to 9. Then now 72 here has been replaced by 9. Remember, MATLAB will always update the current value of the variable. Okay. Another example is that let's say I define x equal to 0.75 semicolon, so MATLAB will not display this. And then now I write an expression e equal to sine of x to the power of 2 plus cos of x to the power of 2. When I press enter, I get a value of 1. So now x here will be, MATLAB will use x equal to 0.75 because I have already defined previously that x equal to 0.75 in this mathematical expression. Okay. So please remember a few things, that variables in MATLAB must begin with a letter. What does this means is that you cannot have 1a equal to 2. For example, you want to start with a number. When you press enter, now MATLAB gives an error. But you can use a1 equal to 3, for example. Then MATLAB accepts this because it starts with a letter. So a1 equals to 3, this appears also here in the workspace, that a1 equals to 3. Okay, and then variables can be up to 63 characters long. Only 63 characters long. Okay, it can contain letter, digits, and underscore. Okay, you can use underscore. For example, you want C underscore 1 equal to 5. So you get here C underscore 1 equals to 5. MATLAB will also display C underscore 1 equals to 5. But we cannot use C dash 1 equals to 4. MATLAB will give an error because dash here is not allowed in the variable name. Okay, only letter, digits, and underscore are allowed. Okay, and then also no space are allowed. No space are allowed in the variable name. For example, you want to define a space 0 equal to 2. This will be this will also give an error. You cannot have space here. Okay. And then there are a few words that have been reserved by MATLAB. These are called keywords. When you type such keywords, it will turn into a blue color. So you know that this is a special MATLAB function that you cannot use as a variable. Such as, for example, break. When you type break, there is a MATLAB command for break, so you cannot use it. You see that it has turned from black to blue. So now this is not allowed to be used for a variable name. Also, for example, case also will turn blue, catch also will turn blue, and so on. You can view the keyword that has been reserved by MATLAB by typing the command is keyword. When you press enter, MATLAB gives a list of keywords that it has already reserved. So these keywords cannot be used as variable name in MATLAB. Okay, some other names that cannot be used as well is like A and S is for answer. It's the current answer of any calculation. For example, if let's say I do 2 times 1 and press enter. Now A and S answer is now equal to 2. Same goes here in the workspace. So if I type A and S, it will give an answer of 2. Okay. Also, like pi, pi cannot be used, has been reserved for pi. So if you type pi, you will get 3.1416 and a few more keywords that MATLAB has already reserved. Like I have mentioned previously, when we define variables, it will be stored in the workspace. We can use the command who to list all the variables in the workspace. So when you type who, you see A1, ABB, B, C, E, A and S, C underscore 1, and X. Exactly what we have in the workspace will be displayed here. And then we can use also the command whos, which will display the size of the variables. And then when we want to clear everything that we have here, we want to clear in the workspace all the variables, we type the command clear. And when we want to clear the command window, we type the command CLC. Okay, so that is the end of the first chapter of MATLAB lesson, which is performing mathematical operations in MATLAB.